So in this video I'll be discussing the basics of how to solve equations that have logarithms in them. So you want to treat these pretty similarly to how you solve equations that have roots in them, in that since logs have a restricted domain, just like roots have a restricted domain, you're going to need to check your answers afterwards. So a typical log equation might look like this. And you'd be asked to solve for x. So I wrote this as the most basic one, but sometimes you might get something with subtraction. Sometimes you might get some variables on this side too, but the process is going to be basically the same. So in order to solve one of these equations, what you always want to do is you always want to get both sides to just be one log. In this case, this side is already just one log. However, here we have ln x plus ln of x plus 1. So here's where you're going to need to use your log rules. And that whenever you have an addition of two logarithms, that's the same thing as having one log with the product of their two arguments. Here, x plus 1. So the left side reduces to ln of x times x plus 1 equals ln of 12. So like I said here, I combined these two into one log because it was addition. You multiply those two things. If it was subtraction, you would have divided them. So now, since both sides you're taking the log, ln of something equals ln of something else, that means those inside quantities must be equal, and we can get rid of the natural logs. Algebraically, you could show that by raising e to the power of both sides of the equation. So from here, you just get a typical algebra equation. This would be x squared plus x equals 12, which means x squared plus x minus 12 equals 0. This is a quadratic equation that we could factor, and we would get x plus 4 times x minus 3. So many students would get to this point and say, well, now this is easy to solve. I know that it's equal x equals negative 4 or x equals 3. But that's incorrect. Just like with the root equation, since you have a function that has a domain restriction, ln, you can't just plug in anything into ln. It has to be positive. We have to check these answers. The other thing is, you don't want to just say, well, since whatever you're taking the ln of has to be positive, as soon as I got a negative answer, I eliminate it. That's not necessarily true. Because if you had something like this, say that was one of our parts of our equation, then plugging in negative 4 would be fine because that would give you actually doing ln of 1. So just because it's negative doesn't mean it's incorrect. You actually have to check it and show that what you're actually taking the ln of works or doesn't. Here you can see that if I were to plug in negative 4 back into this equation, I would be doing ln of negative 4. You can't do that because you can't take the natural log of any number that's not positive. So negative 4 is an extraneous solution. However, 3 works fine because I'm going to be doing ln of 3. Here I'd be doing ln of 4. That works just fine. So we'd only have one answer, x equals 3. So the basic steps again for these log equations is you want to make both sides just equal to one logarithm. And you do that by your log rules. Sometimes it will involve adding like this. Sometimes it will involve subtraction, which would mean division. Sometimes it will involve you having a power on one of the logs. And remember, if you have a power on a log, you can bring it into the front. So, I mean, you're just going to have to use your basic log rules in a variety of ways to get it down to just one log. But as soon as it's one log, it turns into an algebra problem. You always have to check your answers, though, just like with root equations.